This is lesson 7.3, multiplying powers with the same base. Today's target, multiply exponential numbers or powers with the same base. You can set up your Cornell note paper, just like you always do. Put in the learning target, put in lesson 7.3, hit the pause button, and resume when you're ready to go. Okay, I'm going to start with multiplying powers with the same base as a definition. You may not be able to see this on your screen, so I'm going to rewrite it, but this is the same window that you might see in your book. And the definition just says that if you have a power or exponential number that has the same base, the base number is the bottom part, the top part, the number is the exponent. So if I have an exponential number like x to the second power, and I multiply it by another exponential like x to the third power, the bases are the same. That's called a like base. They're alike. When you multiply like bases, all you do is take the exponents and add them together to get x to the fifth. So here's the first example. 12 to the fourth times 12 to the third. It's very simple. These two have the same base, which is 12. Add the exponents. You get 12 to the seventh power. Now if you have a negative number, if it's in parentheses like these are, they're both -5. That means the bases are the same. They're like bases. All you do is add the exponents, -2 and 7. And you get -5. -2 plus 7 is 5, and that's it. Here are 3 more problems that you can try on your own. Hit the pause button and try them, and then resume when you're finished. Okay, again, these are very simple. 8 to the third times 8 to the sixth. 8s are the bases. They're both the same. So I add the exponents. 6 plus 3 is 9. I get 8 to the ninth. B, both bases are 0.5. And when I add -3 and -8 together, I get 0.5 to the -11th power. In C, try to get tricky on you, but they're still like bases. They all contain a 9 as the base. All I have to do is add the 3 exponential numbers together. 6 plus 2 is 8, plus -3 is 5. And that's my answer. Now you could go a little further with these and figure out or calculate what 8 to the ninth power is and get an answer. But in this lesson, really all I'm looking for is that you know how to add the exponents if the bases are the same. Okay, the second problem involves more than just numbers or just variables, but it contains numbers and variables. So the one thing you have to remember is that this part of this problem, 4z to the fifth, really means 4 times z to the fifth. And that's being multiplied by 9 times z to the -12th. Well, if you write it out that way, you can see a little bit clearer that you really have 4 things being multiplied together. And then to make it even more clear, you could rewrite it in a different order like this. 4 times 9, I'm going to put the 2 number parts together, times z to the fifth times z to the -12th. Now once you've seen this, you don't really have to write it out or rewrite it out in this order, but this just helps you understand where my answer is coming from. And now I can take 4 times 9, which is 36, and I can take z to the fifth times z to the -12th. These are like bases, so I add the exponents, and I get z to the -7th. And that's it. So if I use this same strategy in the second example without rewriting it, really what I'm going to do is look at the problem and identify the coefficients or the number parts and multiply them together. 2 times 9 is 18. 18 times 3 is 54. Then I can look at the letter parts. A, B to the fourth, A to the second. Now not every problem is going to give you like bases, and this is an example of that. There are only 2 like bases, that's the A and the A to the second. And anytime you have a letter without an exponent, it's implied to be a 1. So A to the first power times A to the second power is A to the third power, and all that's left is b to the fourth. So these problems really are kind of just like counting problems because you're adding up exponential, or you're adding the exponents of exponential numbers. So here are a couple more problems for you to try. You can ignore the last part and just look at A, B, and C. Hit the pause button, try them on your own, and I'll finish them once you hit resume. Okay, part A. There's just one number, it's 5. The exponents, oops, I lied. Back up. There are two numbers, 5 and 3. 5 times 3 is 15. And then the variables are all x, so they're all like bases. This x has an exponent of 1. Since it's not there, it's implied to be a 1. And then I just have to add the numbers together. 4 plus 9 is 13, plus 1 is 14, so it's 15x to the 14th. B, there are three numbers, -4, 7, and 2. -4 times 7 is -28, times 2 is -56. Only two of the variables are like bases, the c to the third and c to the -2, so I add the exponents. 3 plus -2 is 1, and d squared. And then in the last example, this is the one that just has one number, and that's 12. Only the j squared and the j are like bases. The j has an exponent of 1. Since it's not there, it's implied to be a 1. So 1 plus 2 is j to the third and k to the -2nd. And in these problems, you could take the k, because it has a negative exponent, and move it down below. But for this lesson, I'm more concerned about whether you can see like bases and simplify them than I am about negative exponents. Okay, problem 3. In this problem, it's asking you to simplify two scientific numbers that are being multiplied together. And we talked about this in class. The parentheses on these two scientific numbers mean to multiply. So you could really rewrite this problem like this: 3 times 10 to the 5th times 5 times 10 to the -12th. And just like the last problem, you could take the time to organize or reorganize these numbers so that I write the two whole numbers, 3 and 5, first, and the 2 powers of 10, second, times 10 to the 5th, and times 10 to the -12th. And if you do that, you get 3 times 5 is 15, and 10 to the 5th times 10 to the -12th. These are like bases. You add the exponents and get times 10 to the -7th. But you're not finished, because you have to recognize this problem says write your answer in scientific notation. 15 times 10 to the -7th is not in scientific notation. So let me finish it. First, I'm going to take 15 and write it in scientific notation. To do that, I have to move the decimal point back one place. And I get 1.5 times 10 to the first power. And that's a positive 1 on the 10 because this 15 is a big number, not a small number. Times 10 to the -7th. That just comes from there. And 10 to the first power times 10 to the -7th power is 10 to the -6th power. That's it. So when you multiply two scientific notation numbers together, you can reorganize the numbers like I have done in this example, or you can just recognize that you're going to multiply the number parts and then multiply the powers of 10, and you finish it off by making sure that it's written in scientific notation. Moving on. The fourth and final example is a story problem. And the words in the story problem make this a little confusing, but really all you're doing is multiplying three scientific notation numbers together. So let's read it. At 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules. So you could say that 1 cubic meter of water has this many grams times this many molecules. And then the final sentence asks the question about how many molecules of water does the droplet of water shown below contain. Really, all you're going to do is take this number, 1.13 times 10 to the negative 7th, and multiply it by this number, 9.98 times 10 to the 5th, and then multiply it by this number, 3.34 times 10 to the 22nd. So this problem now just says 1.13 times 10 to the negative 7th times 9.98 times 10 to the 5th times 3.34 times 10 to the 22nd. You just have to take the 3 powers of 10 and multiply them together, and then take the 3 numbers and multiply them together. Well, the powers of 10 part should be easy. Add the exponents. 22 plus 5 is 27, plus negative 7 is 20. Multiplying the other numbers together isn't so easy. So to do that the easiest way, you grab a calculator and you multiply 1.13 times 9.98 times 3.34, and I'm doing it on the calculator right now, and I get 37.6665. Is that number in scientific notation? No. First, it's got too many digits, and second, the decimal point is in the wrong spot. So I'm going to take just this number and write it in scientific notation. Here's the decimal. This is where I want it to be, so I have to move it one place. I get 3.7. Now, I only want 2 digits after the decimal point, and because I have more than that, I'm going to look to the next digit and notice that it's more than 5, so that makes me round this number up to be 3.77. Times, how many times did I move it? Just once. And then I tack on the times 10 to the 20th. So the final answer is 3.77 times 10 to the 21st. And what is that? What am I looking for as my answer? Well, about how many molecules of water. So this is molecules. And that's it. Now, I went through these examples very quickly. Several people have commented that my videos are too long and that I'm going too slow. You have the control. You can go back and re-watch these problems as many times as it takes. Pause them, speed them up, fast forward, do what you need to do, but I'm done. Here is your assignment for 7.3, and we will see you tomorrow.